So we already discussed the intro to sequences and arithmetic sequences. Now we're going to go to geometric sequences. And geometric sequences are really similar to arithmetic sequences, only instead of adding to go from one number to the next, in geometric you're multiplying by a certain common rate. Before it was a common difference d. With geometric sequences it's a common rate, and it's got the variable r. So in this case, hopefully you can see that the common rate is equal to 2. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So I'm just going to write in here that the common rate is 2. As we did with arithmetic sequences, we're going to use A1 for our first term, A2 for our second term, and so on. So A1 is our first term. To calculate A2, which would be the 6 here, so this A1 is 3. Let's put a 3 in here real quick. To calculate A2 here, you see it's 6. You would just take whatever A1 is, so put A1 in there, and then multiply it by R, our common rate of 2. So as you can see right here, A1 is 3 times the common rate of R is 2 would be equal to 6. Okay. So the main thing we're trying to do here is figure out a function that we can use to predict any, or to calculate any number, any term in this sequence, whether it's the 4th term, the 5th term, all the way through whatever term you want, the 100th, you name it. So far we have A1 and A2, so we're going to kind of put this together to create that function. So to get A3, it would just be whatever A2 was times R, and then we end up getting 12. But by doing this, hopefully you see that A2 is right here, A2, which we calculated before. So what you can do is actually, just like we did with arithmetic, is substitute this in for A2. And you end up with a different equation. It ends up being A1 times R, I'm just going to put it in parentheses, times R, from right here. So here's the A2, here's the R. And then I'm going to simplify this right here to get A1 R squared. Okay, and hopefully you can see from the pattern, this one's R squared times A1, this one's A1 times R to the first, and this one would be A1 times R to the 0, which would just be A1. So we got all the way to A3, and you can see the pattern that the power is just 1 less than whatever term you're on. So if you're on 3, the power is 2. If you're on 2, the power is 1. If you're on 1, the power would be 0. So we can kind of use this to guess what A4 would be. A1 R to the 3rd. So now what we're going to do is we're going to use this pattern to create a function that can be used to calculate any term in this sequence. So just like with arithmetic, we're going to use AN, and it's going to be equal to that first term, A1, or C, times R raised to the n minus 1, because if you remember, it's 1 less than whatever term we're on. The power is 1 less. So here it's 3, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is raised to the first power. So you can use this function to determine any term in a sequence. And that's geometric sequences.